This is MCUV. For the NASA Minds 2024 challenge, our team has decided to continue our UVC light water purification device. This year, we decided to add a lot of new elements to our machine, as well as test out new variables and make the overall design more efficient. Now, the design is very similar to last year, but with a few noticeable improvements. First, a circulation pump that will run on the outside of the tank, circulating the water in a closed system from the bottom of the tank to the top of the tank. And then we also have a digital thermometer that will run through the top to get accurate measurements of the water temperature, as well as a new electrical box that will be able to more effectively house the UVC lights, as well as access everything in a quick and efficient manner. And lastly, the systems to hold up the UVC light and quartz glass have been majorly improved with the use of new 3D printed parts. These new 3D printed parts will allow the UVC light and quartz glass to be more stable whilst the pump is running.
Look how slow it's going. It's going pretty slow.
Although we realized throughout the project, to make a tank that is waterproof comes with many challenges. But nonetheless, we didn't give up, and eventually we landed on this new design. Now for this design, it still includes all of the major features of the old design. The only part that changes is that the pump is now on the inside of the tank instead of the outside. And this system provides a much needed solution to the waterproofing difficulties that having the pump and tubing outside of the tank causes. And the noticeable key features of this is the Velcro straps on the flexible tubing, as well as the Velcro on the wall of the tank supported by aluminum tape, which will provide a secure solution to having a flexible tube stay stationary whilst pumping all the water from the bottom of the tank to the top of the tank. And this allows us to do safe testing without having to worry about difficulty waterproofing the tank and having E. coli leak out from it. Although this was not our original design, and definitely not our final design, this design still provides all the key features, and we believe it will work as effectively if we were to put it on the outside or inside of the tank.
Okay. Okay, so the Velcro's in right now. We just stamped it onto the thing.
No,
so I think
blast this.
no, just blast that.
Just blast it by the side.
Yeah. It's fine. This one is fine, and then that one's
Put on the
But now that we made it, let's test it.
We use microbiology methods to test the effectiveness of our modified tank system with the addition of the pump in eliminating bacteria in drinking water. Our success criteria for testing were the following. 1. Reach a bacteria count of 0 CFU per 100 milliliters, and 2. If the addition of the pump increased the rate of bacteria elimination. We began testing by spiking 48 liters of room temperature water in the tank with E. coli to ensure the initial bacteria concentration was high enough for testing. After, the pump was run for 5 minutes so that the added E. coli was thoroughly mixed in the water sample. Following that step, water samples were obtained after 0, 1, 2.5, and 5 minutes of UVC light exposure. Then, each collected water sample was pulled through a membrane filter that collected any remaining E. coli. All filters were transferred onto a petri dish saturated with blue coliform media, the food for the E. coli, and the dishes were incubated for 24 hours. Unfortunately, after several tests, E. coli did not appear on the dishes. First, our team hypothesized that the amount of E. coli added to the water was too little for us to collect and obtain results. In response, we increased the amount of E. coli we added to the tank by a factor of 1,000. After performing this test, however, the E. coli still did not appear on dishes. So then our team wondered if the 70% alcohol we used to clean the inside of the tank was leaving a residue that killed the added E. coli. We then repeated the same testing procedure, which included a trial where the tank was cleaned with alcohol and another trial where the tank was cleaned with soap. Testing showed that the tank cleaned with soap resulted in clear E. coli colonies on the dishes. The clear colonies provided meaningful experimental data. However, our team wondered why the color of the colonies was not the usual red color as we expected. After consulting microbiology professionals and technicians, our team concluded that the pads included in the membrane filtration units are sterilized using a process involving gamma radiation, which can inhibit E. coli growth. Regardless, the data collected from our procedures showed that the tested water did reach a bacteria count of 0 CFU per 100 milliliters after 5 minutes, and the addition of the pump increased the rate of bacteria elimination, meeting our success criteria.
For more information about MCUV's project, please refer to our tech report and our poster. Thank you for watching.